Hi, I'm John Christofferson with Deister Concentrator. Deister Concentrator is a company that was established in 1906, well over 100 years old. One of the main products that we manufacture are concentrating tables. We have 5 different models. The floor-mounted models are the Lab Table, Model 15S. We have a half-size pilot plant table, number 14, and we have a full-size floor-mounted number 6 single-deck table. Also, we have 2 tables that are suspended. One is a Model 99 double-deck table. The other is a triple-deck Model 999 table. Today, we're going to take a look at the Deister Lab Table. This particular unit is utilized at universities and small mining companies. Also large mining companies for their test labs where they're testing to see how their flotation circuits are operating. The purpose of the lab table is to achieve a metallurgical performance, a grade recovery, which then can be scaled up to full-size operation. One of the main advantages of the Deister table over some of our competitors is that our deck is a rhomboidal shape type deck, which increases the cleaning area at the middling corner of the table. This allows for higher capacities as well as increased grades and recoveries. Another advantage is that we have a riffling system for the granular type sand material, and we also have a specialized riffling system for the very fine slime type material. Okay, we're going to be running a short test here. The material we're going to be running is a combination of white silica sand and some steel and iron grit. Some of the minerals that are concentrated on Deister shaking tables include tin, tungsten, gold, silver, chromite, cobalt, manganese, beach sands, rutile, zircon, ilmenite, strontium minerals, lithium minerals, manganese, rare earths, and in recycling, chopped copper wires, crushed circuit boards. You can see the feed box where Josh is feeding the table. This is the dressing water box, that in combination with the tilt. One of the main adjustments, probably the main adjustment on the table through the line of drive to the concentrate corner is an upward slope. We're going to put the cutting pan in to cut a concentrate off the table now. You can see we have a pretty definitive line here. So this would be the high gravity concentrate with a density of about 3.5. Silica sand has a density of about 2.6 to 2.7. So that's going to be going to the mid lanes and to the tailings. We have a sliding cutting pan here for the tailings. This is the increased area of the middling corner we talked about for the rhomboidal shape of the table, whereby allows us to have increased capacities as well as better grades and recoveries. The side tilt is controlled with a hand wheel back here. You can see that. The end elevation is controlled with a wheel underneath the main channel back here. The speed of the table is controlled with a wheel back here. We have a Verispeed shiv on the motor, so we can increase and decrease the speed depending on the particle size of the material that we're treating on the table. This is where we're cutting the concentrate. You can see I have a pan here, and I can cut the concentrate all the way down to where we're getting a middling product. So in this outer launder is where we're cutting the valuable mineral, and then we have a high gravity middling, low gravity middling, and of course we talked about the tailing off the long side of the table there. You can see the middling product here, a combination of the iron and the sand. And this is just the iron, this area here. You can see it's sand-free. If you have any questions about the Deister shaking table, give us a call or visit us online.